Welcome to the deep dive. Today, we're going to do a deep dive into AI and digital pathology.
Okay.
But with a twist.
Okay.
We're going beyond cancer.
Right.
You want to know how AI can be used for other diseases? And we've got some really cool research to unpack.
Yeah.
We'll be looking at a presentation by Prof.Dr. Sülen Sarıoğlu'nun.
Okay.
It's called Digital Patolojide, Yapay, Zeka.
Mm-hmm.
And some cutting-edge research articles on AI and nephropathology.
Right.
And even like a cool little anecdote about the history of how we measure and analyze these diseases.
Sounds fascinating.
It's really interesting stuff.
Yeah, because it really kind of challenges a common assumption.
Yeah.
You know, when most people hear pathology, the first thing they think of is cancer diagnosis.
Oh, totally.
But that's really just a small piece of the puzzle.
It is. When you think about pathology, I mean, what comes to mind?
Yeah.
Like for me, it's that picture on the cover of Siddhartha Mukherjee's The Emperor of All Maladies,
Right.
the cancer book.
Right.
And even Prof.Dr. Sarıoğlu uses that in her presentation.
Mm-hmm.
But it's interesting because cancer only makes up about 10 to 30% of what pathologians actually deal with.
That's right. The other 70 to 90% is a huge spectrum of other conditions.
Yeah.
Which often gets overlooked when we talk about AI in healthcare.
Totally. And this is like the aha moment.
Yeah.
Dr. Sarıoğlu's presentation really highlights this gap perfectly.
Mm-hmm.
AI is making huge strides in digital pathology.
It is.
But the focus is really heavily skewed towards cancer.
Right.
It's like everyone's looking at one side of the room, while this whole other universe of non-neoplastic diseases is just waiting to be explored.
And there's a few reasons for that.
Okay.
One that Dr. Sarıoğlu points out is the role of pharmaceutical companies.
Okay.
Because there's a lot more funding and support for AI in cancer diagnosis because of the potential for new cancer treatments.
Mm-hmm.
But for other diseases, that financial incentive isn't always there.
Right.
Even though the need for better diagnostics is just as urgent.
Yeah, totally. That's a really good point. But before we even get into like the specifics of where AI can make a difference, let's just like zoom out for a second and appreciate the sheer scope of what we're talking about.
Yeah.
Dr. Sarıoğlu has a slide in her presentation called OISA,
Right.
which basically means however, and it's like she's throwing open a giant door, and behind it is this massive list of conditions where pathology is crucial. Mm-hmm. She's got idiopathic pulmonary fibrosis,
right.
gastritis colitis, salivary gland disorders,
wow,
duodenal malabsorption syndromes, nephropathology, infectious diseases, inflammatory diseases. Mm-hmm. It goes on and on.
It does, yeah. And some of those are notoriously difficult to diagnose.
Oh, yeah.
Take idiopathic pulmonary fibrosis, for example.
Okay.
It's a devastating lung disease, and it has a really variable course. Diagnosing it accurately and early can be really challenging because it relies heavily on a pathologist's interpretation of biopsies.
And that's where AI could be a game changer.
Yeah.
Imagine AI algorithms that can analyze those biopsies and pick up on subtle patterns that might not even be visible to the human eye.
Right.
It could revolutionize how we diagnose and treat these complex diseases.
And you know, this isn't a completely new idea.
Okay.
This quest for more precise and objective ways to analyze diseases.
Yeah.
It's been going on for decades.
Right.
Dr. Sarıoğlu even shares this anecdote about her early career.
What's that?
Where she was working on quantifying kidney scarring.
Okay.
Even back then, pathologists were looking for ways to measure and analyze disease with greater accuracy. Mm-hmm. And that work really laid the groundwork for the AI-powered tools that we're talking about today.
So we're seeing that evolution. It's those same questions that pathologists have been asking for years. How much?
Right.
What kind?
Yeah.
How severe?
Yep.
And now we're applying the power of AI to try to find those answers.
And those answers have the potential to transform how we diagnose and treat a whole range of diseases.
Totally. Now, you're specifically interested in the potential of AI in nephropathology.
I am.
The study of kidney diseases.
Yes.
What is it about nephropathology that makes it particularly well-suited for AI?
Well, nephropathology is really fascinating, and I think it's already primed for AI to make a big difference.
Okay.
And one of the slides in Dr. Sarıoğlu's presentation, I think, really brings this home.
Okay.
It's called Enderbranch Nephropathology, which really highlights how specialized this field is.
So what's the key takeaway there?
The takeaway is that nephropathologists really have to be masters of connecting the dots.
Okay.
They're looking at clinical data, what they see under a light microscope, results from immunofluorescence, and even electron microscopy.
Wow.
So imagine trying to piece together a puzzle
Okay.
but your pieces are coming from 4 different boxes.
It's like a next-level detective game.
Right.
But instead of clues, you're dealing with like these tiny little structures in the kidney.
Exactly. And even the tiniest differences in how those structures look can mean wildly different things for a patient's diagnosis. So a subtle change in the shape of a glomerulus.
And remind me what a glomerulus is again.
Oh, right. Sorry. So that's the tiny filtering unit in your kidney.
Okay, got it.
So a change in the shape of that or the pattern of staining in a biopsy, those can be the difference between like a harmless condition and a serious kidney disease.
Wow.
And this is where AI has the potential to really shine by helping pathologists analyze those nuances more effectively.
So it's like giving pathologists a superpowered magnifying glass.
Exactly.
They're already experts at spotting those subtle clues.
Right.
But AI could help them see even faster.
Exactly. And Dr. Sarıoğlu'n's presentation points to 3 main areas where AI can make a real impact in nephropathology.
Okay.
Easy wins, advanced challenges, and research opportunities.
I like it breaking it down like that.
Yeah.
So let's start with the easy wins.
Okay.
What kind of tasks are we talking about there?
So think of it as tasks that are really time-consuming for pathologists,
Okay.
but relatively straightforward for AI. So, for example, counting glomeruli in a biopsy, which is essential for diagnosing a lot of kidney diseases. But it can be incredibly tedious to do manually.
Oh, yeah. I can imagine it'd be like counting grains of sand.
Exactly.
Yeah.
But AI can be trained to do this quickly and accurately. Other easy wins include things like quantifying IHC staining, which helps to identify specific proteins in the tissue samples.
Got it.
And measuring interstitial fibrosis.
And what's that?
So that's basically scarring in the kidney.
Oh, okay. So AI can take over these kind of like repetitive tasks and free up pathologists to focus on like the more complex aspects of diagnosis.
Precisely.
It's like having a tireless assistant in the lab.
Exactly.
I like it.
All right, so let's move on to those advanced challenges.
Okay.
So here, AI is being used to tackle tasks that require a higher level of analysis. One great example is segmenting and classifying glomerular lesions.
Okay.
So these are abnormalities in those glomeruli.
Okay.
And they can be really diverse and difficult to categorize.
That sounds really complicated. How does AI even begin to like make sense of that?
So it's all about pattern recognition.
Okay.
AI algorithms are trained on thousands of images of glomerular lesions.
Okay.
And they learn to identify and classify them based on subtle features that might not be immediately apparent to the human eye.
So the AI is essentially learning to see patterns in those images.
Yes.
In the same way that like a trained pathologist would.
Exactly.
But potentially with even greater accuracy and speed.
Exactly. And that level of precision in diagnosis can have a huge impact on patient care.
It's incredible to think about, but it sounds like we're just scratching the surface here.
Yeah.
What about the research opportunities?
Right.
What role can AI play in actually like advancing our understanding of kidney diseases?
Well, think of it this way. AI thrives on data. And in nephropathology, we're seeing this huge surge in the amount of data that's available.
Okay.
Thanks to large-scale research initiatives.
Yeah.
Like one example is the Neptune study. And that's brought together this massive amount of data from patients with nephrotic syndrome.
Okay.
Which is a serious kidney disorder.
Yeah.
So you're basically creating this giant library of information about kidney disease that AI can then be used to analyze.
Like giving it the ultimate training manual for understanding kidney diseases.
Exactly.
Okay, I like that. But let's get down to brass tacks here.
Okay.
Beyond the theory, beyond the potential.
Right.
Are there actual, like, concrete examples of AI delivering results in nephropathology?
Absolutely. There are some really exciting studies underway that demonstrate the real-world impact. For instance, one study tackled the challenge of glomerulus segmentation.
Okay.
Remember, that's identifying the individual glomeruli in a biopsy.
Right.
They used a clever combination of 2 AI techniques.
Okay, hit me with the details. What were the techniques?
All right, so they used a combination of semantic segmentation and boundary detection.
Boundary detection.
I know those sound like really technical terms.
Yeah.
But bear with me,
Okay.
because they're actually quite intuitive.
Okay.
Imagine you're looking at a satellite image of a city. Semantic segmentation would be like coloring all the buildings red, all the roads blue, all the trees green. It's about teaching the AI to recognize different types of objects in the image.
Okay, that makes sense.
Okay, so then boundary detection takes it a step further.
Okay.
It's like outlining each building, each road, and each tree with a precise line.
Got it.
It's about defining the exact boundaries of each object in the context of nephropathology.
Yeah.
The researchers combined these two techniques to teach the AI to identify and precisely outline each glomerulus in a biopsy image,
Cool.
no matter what type of stain was used.
So no matter how the tissue sample is prepared, the AI can still pick out those glomeruli.
Precisely, and that's a huge step forward.
Yeah.
Because it means that this AI tool could potentially be used
Yeah.
to automate the analysis of a wide range of kidney biopsies,
Wow.
making diagnosis much faster and more efficient.
That's a really powerful example of AI in action.
Mm-hmm.
But what about diagnosing specific kidney diseases? Are there examples of AI being used for that?
Absolutely. One study focused on IgA nephritis,
Okay.
which is a common type of kidney disease.
Mm-hmm.
That can actually be really tricky to diagnose accurately.
Really?
Yeah, the researchers wanted to see if AI could be trained to classify IgA nephritis using the Oxford classification system.
Hold on, the Oxford classification system.
Yeah.
Isn't that a really complex system
It is.
that even trained pathologists sometimes have trouble with?
You're absolutely right.
Okay.
It involves analyzing various features of the biopsy, like the degree of inflammation, the scarring,
Yeah.
assigning a score based on the severity.
Wow.
It's not a simple task.
No, it doesn't sound like it.
No.
So what happened?
Well, that's the remarkable part.
Mm-hmm.
The AI was trained on this large data set of biopsy images that had been scored by expert pathologists
Okay.
using the Oxford system.
Mm-hmm.
And the results were really impressive.
Okay. What happened?
The AI learned to classify IgA nephritis
Wow.
with a high degree of accuracy, matching the performance of those expert pathologists.
So the AI learned to speak the same language as the pathologist.
Exactly.
That's awesome.
And what this means for patients in the real world is that AI has the potential to streamline the diagnosis of this disease, which could lead to faster treatment and better outcomes.
Yeah.
Imagine a future where AI can help doctors quickly and accurately diagnose this condition, even in areas where access to specialist pathologists might be limited.
Totally. It could be huge for healthcare equity.
Exactly.
Okay, so we've talked about how AI can help diagnose existing kidney diseases.
Right.
But what about predicting future problems?
Yeah.
Can AI be used to identify patients who are at risk of developing kidney disease?
That's a great question.
Yeah.
And it leads us to one of the most exciting frontiers, I think,
Okay.
in AI and nephropathology, which is the ability to actually predict kidney function decline.
Wow. Okay.
And one study that Dr. Sarıoğlu mentions used this really fascinating approach
Okay.
called unsupervised learning.
Unsupervised learning. Okay.
Yeah. Have you heard of this?
I have, but just remind me how it works.
Okay. So in supervised learning, we feed the AI labeled data.
Okay.
We tell it what it's looking at.
So like we're the teachers.
Exactly.
Got it.
But in unsupervised learning, we give the AI this mountain of data.
Okay.
And we essentially say, go figure it out.
Go figure it out.
Yeah, we don't tell it what to look for.
Wow.
We let it discover patterns and relationships in the data on its own.
It's like the AI is wandering around a library without a librarian.
Right, exactly.
Wild.
So in this study, they gave the AI access to this huge data set of kidney biopsies and clinical information from patients. And it crunched through all of this data, looking for any hidden patterns or connections that might be related to kidney function decline.
And what did it find?
Remarkably, the AI was able to identify patterns in the data that could be used to predict which patients were more likely to experience a decline in their kidney function over time.
Wow. So it's like having a crystal ball for kidney health?
Yeah.
That's amazing.
And that's a game changer.
Totally.
Because it means that AI could potentially help us identify individuals who are at risk of developing kidney problems, even before they show any symptoms.
That's incredible. Early intervention can make a huge difference for those patients.
Exactly.
Okay, so we've seen how AI can handle those easy wins in nephropathology. We've talked about the advanced challenges it's starting to tackle.
Right.
We've even seen real-world studies that show its impact on diagnosis and prediction.
Yeah, it's really exciting.
It's clear that AI has the potential to, like, revolutionize the field.
It does.
But before we get too carried away here, it's important to remember one crucial thing.
Okay, what's that?
AI isn't about replacing pathologists. It's true. It's easy to get caught up in all the amazing things AI can do.
It is.
But at the end of the day, it's a tool, right?
Yeah.
It's not about replacing the expertise of a trained pathologist.
You're absolutely right. And Dr. Sarıoğlu actually addresses this directly in her presentation.
Okay.
She has a slide with this puppet image.
Okay.
And it's labeled pathologist.
Okay.
It's a little whimsical.
Yeah.
But it makes a really important point.
Okay, what's that?
Pathologists are the puppeteers.
Okay.
They're the ones in control. They're the ones bringing together all these different pieces of information.
Okay.
What they see under the microscope.
Yeah.
The patient's clinical history.
Right.
Digital images. And increasingly molecular data.
Yeah.
AI can help them analyze those pieces more effectively. But it's still the pathologist who's making the diagnosis.
It's like we're giving the pathologist this more sophisticated toolkit.
Exactly.
But they're still the master craftsperson.
Right. And Dr. Sarıoğlu argues that pathologists should be the ones driving the development of AI in their field. They're the ones on the front lines,
Right.
They're seeing the challenges and the needs firsthand. So they should be the ones guiding the development of these tools to make sure that they're actually useful in the real world.
Totally. So it's about collaboration, not replacement.
Exactly.
And I think a crucial aspect of that is making sure that these AI tools are actually integrated seamlessly into a pathologist's workflow.
Yes, absolutely.
Okay.
Dr. Sarıoğlu really emphasizes the importance of smooth integration with lab and pathology information systems, what we call LIS, PIS systems.
Okay.
And these systems are how labs manage all their data.
Right.
So AI tools that can talk to these systems are essential for smooth and efficient analysis.
So it's like making sure that all the pieces of the puzzle actually fit together.
Exactly.
But even with perfect integration, we can't forget about quality control.
Right.
Right? Do we make sure that these AI tools are producing reliable results that pathologists can actually trust?
That's a really important point.
Yeah.
And Dr. Sarıoğlu is very clear about the need for rigorous quality control throughout the entire digital pathology process.
Okay.
From the moment a slide is scanned to that final AI analysis. And this includes things like making sure that the images are high quality, that the algorithms are validated,
Okay.
and that the results are reviewed by experts.
So it's about building trust in these tools every step of the way.
Exactly.
And as AI and pathology evolves, it feels like we're on the verge of something even bigger.
Yeah, what's that?
Integrating molecular data into the mix.
Right? It's really exciting.
Yeah. What are your thoughts on that?
It is incredibly exciting, and Dr. Sarıoğlu even touches on this with a slide titled In Silico Morphomolecular Research.
Okay.
And it's basically about connecting the dots between the morphology, what we see under the microscope, and the molecular level, like patients' genes.
So instead of just looking at the structures of the cells and the tissues, we're starting to understand the underlying genetic code that's driving all of it.
Exactly. And this is where AI can really shine. We're talking about analyzing massive data sets.
Okay.
Think about projects like the Neptune Consortium we talked about earlier, or the Pima Indian cohort, which has been studying diabetes and its complications for decades.
Wow.
These projects have generated this treasure trove of data linking genetic information to disease.
That's amazing.
Yeah. And AI can sift through this data and find those hidden correlations between specific gene variants and how the disease actually manifests itself.
So it's like we're looking for a genetic signature for different diseases.
Exactly.
It's wild.
And then we could potentially identify people who are predisposed to certain conditions based on their genes.
Wow.
Even before any symptoms appear.
This is where things start to get really futuristic.
I know, right?
But we can't expect AI to just figure all this out on its own, can we?
You're right, we can't.
It still needs guidance.
It does.
Especially when we're talking about something as complex as the human genome.
Absolutely. And that's why Dr. Sarıoğlu advocates for this semi-supervised approach to training AI in this area, where we can use the decades of knowledge that pathologists have accumulated about disease morphology and use that to guide the AI's learning process.
So it's like giving AI a head start.
Exactly.
Okay.
Like pointing it in the right direction.
It's about combining the best of both worlds.
It is.
The pattern recognition power of AI and the deep expertise of those human pathologists.
Absolutely.
This has been an incredible deep dive. We've
Yeah.
covered so much ground.
I know, right?
From this often overlooked world of non-neoplastic diseases to the cutting edge of AI in nephropathology.
It's amazing.
What are some of the key takeaways you hope our listeners are walking away with today?
Well, first and foremost, I hope they gain a new appreciation for the potential of AI in this field,
Totally.
especially for diseases beyond cancer.
Yeah.
It's a field that's really ripe for innovation, and the possibilities for improving diagnosis, treatment, and even prevention are just so exciting.
And I hope our listeners also come away with a sense of optimism, but also a grounded perspective. AI isn't a magical solution, and it's not about replacing human expertise.
No.
It's about empowering those pathologists with better tools,
Exactly.
enabling them to do their jobs even more effectively.
Absolutely. It's about collaboration, careful integration,
Yeah.
and a commitment to using these powerful tools responsibly and ethically.
Really well said, and perhaps most importantly,
Yeah.
we hope this deep dive has sparked your curiosity
Yes.
and your imagination.
The world of AI in healthcare is evolving so rapidly.
It's so fast.
And the possibilities are truly endless.
They are. What role do you envision for yourself in this evolving landscape?
It's a big question.
It is. What questions will you ask? What problems will you solve? How will you contribute to shaping the future of healthcare?
It's up to all of us.
It is. Keep exploring.
Yeah.
Keep questioning.
Keep learning and keep diving deep.
I love it.